Good morning, welcome to SAKALAVIDYA YouTube channel. So welcome to our all regular viewers. In the last session actually we have completed up to 13 problems in permutations combination chapter. So we have been discussing permutations. Next that will be continued, and moreover in that actually we will discuss first basic level questions, and besides some level 1 level 2 problems also we will discuss in this session. So I planned in such a way you need to understand. Okay, yes, 14th question we need to discuss. Still we have 4 minutes time, so let them be joined. So all our regular viewers. Okay, right, still joining. Once again, good morning all. Good morning everybody. So all of you like subscribe and share. So okay, your chart need to be confined to the academic issues itself only. That means you need to discuss regarding to this chapter. So today we are going to discuss permutations part 4. So you need to confine to our classes itself only. You should not ask about the when will be the examinations will be held. That I don't have the idea, because that is not necessary for us also. So you'll understand. Thank you. You need to do it. You need to do. You need to do. Yes. Yes. Right. 2 minutes time is there. So that I will wait up to 2 minutes. Then after that 9:30 sharp I start the class. Are you ready with notebooks and pens? So all of you need to watch till the end of the class, because definitely theory of equations will be dealt, don't worry. So each and every chapter will be dealt. No chapter will be left. No chapter will be left. Even whatever actually unfinished work is there, that can be completed. Don't worry. Yes. Today evening session 4:30 you have the circle classes. Because I updated the notification on my permutations, so now I have been continuing the permutations, but evening onwards we have circles. Tomorrow again circles will be continued. Oh, very good, very good. When some offline viewers are there, online viewers are there, welcome to everybody. Not only online, even offline also I welcome offline viewers, because everybody is important to us. Actually our aim is to reach to all the corners of at least both Andhra Pradesh and Telangana, even sometimes even all the parts of our country. Okay, thank you. So let us start. So today question number 14. Permutations part number 4. Question number 14. Because this chapter needs actually the more explanation, that's why it takes time, don't worry. But problem solving is very easy, only one step without paper pen you can perform in the examination. But I need to use all the steps, that's why you need to wait for at least for each problem at least 2 to 3 minutes or 4 minutes, sometimes 5 minutes also. But in the examination you may take only just I think 1 minute time itself only. Any problem of based on PC you can complete within 30 to even sometimes 30 seconds, even 60 seconds, even 1 minute also, no problem. But I need to take more time. But I need to explain that you need to understand. The number of three digited numbers that can be formed using 1 2 3 4 5, using the digits 1 2 3 4 5 any number of times. This condition is there, any number of times. This is the keyword in this problem. Any number of times is first option 125, second option 118, third option 120, fourth option 116. This is the question. Thank you. Okay, I will make a plan. Right. The number of three-digit numbers that can be formed using 1 2 3 4 5 digits any number of times. Any number of times is important with repetition. So with repetition means actually three-digit number. That means 3 blank places need to be filled with 5 digits with repetition. That you need to remember. So with repetition means the first place can be filled 5 ways, second also 5 ways, third also 5 ways. That's why your solution required number of ways is equal to required number of three-digit numbers. Three-digit numbers equal to 5 into 5 into 5. That is 5 cube. So whose value is 125. That means first option is the right option. First option is the right option. This is called, actually this is the keyword you need to remember. Any number of times. That means with repetition. This concept we need to use the 15th question. Let us move to the 15th question. 15th question. So circles not yet completed. The number of 4-letter words that can be formed that can be formed using the letters of the word, of the word explain, EXPLAIN, explain which begin with an vowel, always the four-letter word should begin with an vowel. When repetitions are allowed, when repetitions are allowed is first option 1029, second option 118, third option 120, fourth option 116. This is the question. Right. See, the number of four-letter words need to be formed using the letters of the word explain, which begin with an vowel. This is condition, and also this is very important. Repetitions are allowed. So that means first of all we need four-letter words. That means you take four blank places. 1, 2, 3, 4 blank places. 4 blank places should be filled with the letters of the word explain. So first write down here number of letters. How many number of letters are there in the word explain? 1, 2, 3, 4, 5, 6, 7 is there. Number of vowels. What are the vowels here? Number of vowels means actually see A, I, E. That means number of vowels is 3. A, comma, E, comma, I. A, comma, E, comma, I. So that means now what we need to do? So always begin with, here condition is there. 4 letters of the word begin with an vowel. This is the key word in this problem. This is a key point. So begin with an vowel. Begin with an vowel means first place should be filled with the 3 ways. This can be filled 3 ways. That's only. But whereas actually here see, other we can make use of the with repetition. With repetition is there. How many letters are there here? 7. So this can be filled 7 ways. This can be filled 7 ways. This can be filled 7 ways. So that means first work can be done in 3 ways. Second work can be done 7 ways. Third work can be done 7 ways. Fourth work can be done 7 ways in succession. So the required number of ways is equal to 3 times 7 into 7 into 7. So that is the answer. So therefore now number of required 4-letter words equals to 3 times 7 into 7 into 7 into 7, 21 into 49. So 21 into 49 means 49 into 21, 49, 98. So 9, 12, 1029. So this equals to 1029. 29. So first option is the right option. So all of you understood? Okay. Right. Very good. So option 1. All of you understood? Thank you. Right. Shall I move to 16th problem now? Shall I move to 6th problem? Now the 16th one. 16th problem. 8 different letters. 8 different letters. 8 different letters of an alphabet are given. Out of 26, 8 different letters of an alphabet are given. Words of, here restriction, words of 4 letters, consisting of 4 letters. Words of 4 letters from these are formed, are to be formed, or are formed. The number of such words with at least one letter repeated is. One letter repeated is. This is the question. Right. First option 8C4 minus 8P4. Second option 8 to the power of 4 plus 8C4. Third option 8 to the power of 4 minus 8P4. Fourth option 8 to the power of 4 minus 8C4. Right. Here see, 8 different letters of an alphabet are given. Words of 4 letters from these are to be formed. The number of such words with at least one letter repeated. At least one letter repeated means we have one formula. For example, there are n different letters of alphabet are given. Words of smaller letters from these are to be formed. Number of such words at least one letter repeated is n to the power of r with repetition minus without repetition. So that we need to write. Formula is actually here solution. Here n equals to 8 total, 4 required 4, r is equal to 4. So required number of letters is equal to, as for the condition, required means at least one letter repeated, that is n to the power of r minus npr. N means 8 to the power of 4 minus 8p4. You need not simplify, don't worry. Check the options. What is the correct answer? Yes, option 3 is the right option. Option 3 is the right option. 17th question. 17th one. A letter lock consists of three rings each marked with five different letters. Five different letters. Number of maximum attempts to open the lock is first option 124, second option 125, third option 120, fourth option 75. This is the question. Okay. A letter lock consists of three rings, each marked with five different letters. Number of maximum attempts to open such lock is, okay, that we need to do it. Number of maximum attempts to open the lock. So to open the lock means, actually here see, for example, this is a first lock, second lock, third lock. For example, say A, B, C, D, E. A, B, C, D, E. A, B, C, D, E. So how many ways can you rotate this one now? This can be rotated how many ways? 5 ways. This also can be rotated how many ways? 5 ways. This also 5 ways. So the maximum attempts we need to make, this first one is 5, second one is 5, third one is 5. So therefore solution, number of maximum attempts to open the lock is equal to 5 into 5 into 5, that is 5 cube. So this is equal to 125 is the second option. But sometimes the question may be given in, actually to get confusion in the examination, this may be given like this. A letter lock consists of three rings each marked with 5 different letters. The number of successful attempts to open the lock is unsuccessful attempts. Unsuccessful attempts means number of maximum attempts minus number of successful attempts. Successful attempt is only one. That means 125 minus 1, 124. But this question is 125 only. Yes. This is maximum of number of attempts means including successful and unsuccessful. Always successful is only one. Unsuccessful will be maximum minus successful. It's wonderful. Unsuccessful is 124. Right. Not option 2. This is 125. Second option only for this problem. Right, thank you. I hope you might have understood my concept. Eighteenth one. The number of different arrangements different arrangements that can be made out of Mississippi, Mississippi, Mississippi is. This means actually without repetition only. Right. First option is 10 factorial. Second one is 10 factorial upon 4 factorial times 2 factorial 2. Third option 10 factorial upon 4 factorial. Fourth one is 9 factorial upon 4 factorial. Okay. So now let us come to this problem now. The number of different arrangements, permutations can be made out of the letters of the word Mississippi. Yes. First solution, write down number of letters. So number of letters is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total number of letters is 10. So number of eyes is equal to 1, 2, 3, 4. These 4 are same. First kind. So number of yes, 1, 2, 3, 4. Number of yes equals to how many? That is also 4. That means 2 are different. Therefore required number of arrangements that can be made without repetition. This is, you remember, condition has not been imposed. 10 factorial upon first kind 4 factorial, second kind 4 factorial, or this can be written sometimes 10 factorial by 4 factorial whole square. This also wonderful. Third, nineteenth question. Okay, I will check now. Okay. Okay, Sai Pranit, thank you. 19. Number of words that can be formed with the letters of the word correspondence is. Okay, first option 14 factorial upon 2 factorial raised to 4, 3 factorial raised to 2 or 3 factorial squared. Second one 14 factorial upon 2 factorial all to the power of 4 times 3 factorial. Third option 14 factorial upon 2 factorial upon all to the power of 4 2 factorial. Fourth option is 14 factorial upon 2 factorial whole cube times 3 factorial. Just like previous problem itself only, that you will do it, no problem, but let us do it now. It's clear from the fourth options. Total number of letters in the correspondence is 14. It's clear. Without counting we can say number of letters equal to 14, but in which first number of C's write down. C's 1, 2. Number of C's equal to 2. Number of O's 2. Number of O's 2. Number of R's 1, 2. Number of R's 2. Next number of E's 1, 2, 3. Number of E 3. Anything now? Is completed? Yes. Number of N's. So we need to do clear observation. 2 is completed. Rest are different, I think so. Number of S is only 1. Okay, 3 plus 2, 5 plus 2, 7, 7 plus 2, 9, 9 plus 2, 11. 3 are different. Okay, correct now? Right now. Let us write now number of ways is equal to 14 factorial upon 2 factorial, 2 factorial into 2 factorial into 2 factorial, 2 factorial raised to 4 into 3 factorial, That means second option is the right option. Right. That question will not appear, I think, Akshay. That question may appear in the 2021 examination because already it's over. This is 2020. So if I were you a paper setter, then you will give that question in the examination. I hope so. All the best to you. 20. 20. Number of ways to rearrange the letters of the word. The letters of the word. Letters of the word. Cheese. Cheese is. Right. The number of ways to rearrange the letters of the word cheese. Letters of the word cheese is. First option is 100. Second option is 115. Third option is 119. Fourth option is 120. Enough. Okay. The number of ways to rearrange the letters of the word cheese is. First, the total number of ways we need to find out. After that, rearrangements. Rearrangements means already cheese has been arranged. That word we need to subtract. 1 we need to subtract out of 120. So first let us write now. Solution. Number of letters. Total number of letters. So number of letters equals to here 1, 2, 3 plus 3, 6. Now number out of them, number of is equal to 3. Therefore total number of arrangements is equal to arrangements equal to 6 factorial upon 3 factorial. 6 factorial means 6 into 5 into 4 into 3 factorial upon 3 factorial. 3 factorial gets cancelled. This is 120. But in out of 120, cheese also one of the letters will be there. But that need to be subtracted because this is the keyword. It's very important word in this problem. Keyword. This is called keyword. So as for this keyword, rearrangements, required number of rearrangements equals to 120 total minus this word cheese we need to subtract. So we get 119. This is the right option. So third option is the right option. Sumant, third option is the right option. So last time in the Ecet examination, very simple questions based on the concepts were asked. The number of ways n things can be arranged around the circle and such questions given, but they are actually match type questions given, but based on concepts itself only. 21st question. The number of the number of ways can 8 students yes, 8 students sit round the table or first option 8 factorial, second one is 7 factorial, third one is 8 factorial upon 2, fourth one is 7 factorial upon 2. That means 8 students are to be arranged around a circle. That means this is circular permutation, not linear permutation. That means the number of ways of arranging n objects, n different or distinct objects around a circle are circular permutations. The number of circular permutations are n minus 1 factorial. That is the formula. So that means actually here solution, here n equals to 8, the number of ways is equal to n minus 1 factorial, that is 8 minus 1 factorial equal to 7 factorial. So for example, beads necklace is there, you need to multiply with half, 1 by 2. But students or any objects other than flowers, beads, necklace problem, we need to do like this only. Twenty-two. The number of ways that 8 beads of different colors be strung as necklace. Necklace means round only. Necklace is first option 25-20, second option 28-80, third option 43-20, fourth option 50-40. 50-40. Yes, absolutely correct. So this problem is very carefully, you need to check this necklace. This necklace is the key word for us. Necklace means half times n minus 1 factorial. You need to remember. So 8 beads. So therefore here n equals to number of beads or flowers. Beads equals to n equals to 8. Therefore number of ways is equal to half times n minus 1 factorial. That is half times 8 minus 1 factorial. That is 7 factorial upon 2. 7 factorial is 50-40. 50-40 divided by 2. 225 ja, 220 ja, 25-20. That means first option. Venkateshwarlu Narla, check Your option? Right. 23. 23. 23. Okay, after long time, Dishwank, what happened? Avinash, Sumant. Okay. The number of ways in which five different enough Sai Pranit. 5 different colored flowers be strung, that means made, be strung in the form of a garland, is first option 24, second option 12, third option 16, fourth option 22. Right. The number of ways in which 5 different colored flowers strung in the form of a garland. Here garland is the keyword. So understood now. So that means here number of different beads or flowers, n equal to 5. So number of ways equal to half times n minus 1 factorial. Okay, this equals to half times 5 minus 1 factorial. This is 4 factorial upon 2. 4 factorial means 24 upon 2, whose value is 12. Am I correct? So second option is the right option. Everybody, even you are doing calculations also. Wonderful through chart. Twenty-fourth. Last time the same type of actually 23rd, 22nd, 23rd model problems have been asked in the examination. Right. The sum of the see, those who have not actually watched the previous videos, they are available in the playlist. That is permutations and combinations 1 and 2. You can watch. And next come to this one, you will have the good idea. Mokhi Punvita. The sum of all the numbers formed by taking all the digits from 2, 3, 4, 5 is last year in permutations and combinations easy problems were given. Shiva Ganesh. The sum of all the numbers formed by taking all the digits from 2, 3, 4, 5. Here actually without repetition is not mentioned means with repetition is not mentioned means without repetition only we need to consider. That means sum of all the numbers formed by taking all the digits from 2, 3, 4, 5. That means by taking all the numbers, all the digits from 2, 3, 4, 5, we can form 4-digit numbers. The sum of the possible 4-digit numbers formed by taking all the digits from 2, 3, 4, 5 without repetition we need to find out. So that is the question. Okay, for this one, note down first option 666 0000. Second option 93325. Third option 933240. Fourth option 103680. This is the question. Okay. That means we have one shortcut formula. All of you note down that shortcut formula. Shortcut formula. The sum of all the numbers formed by taking all the digits from A1, A2, A3 and so on AN. 0 is not there. Is given by n minus 1 factorial into 11111 dash n times into A1 plus A2 plus A3 plus so on plus AN. This is the shortcut. Right. So with the help of this shortcut we need to solve this problem now. 24th solution. Here digits are 2, 3, 4, 5. The sum of all the numbers equals to formula n minus 1 factorial into 1111 equivalent to number of digits into A1 plus A2 plus so on dash dash AN. This equal to here 4 minus 1 factorial. Here 4 ones you need to write into 2 plus 3 plus 4 plus 5. This is 3 factorial into 111 2 plus 3 4 5 5 plus 5 10 14. This is okay, right. 3 factorial is 6 into 1 1 1 1 into 14. This is 6 6 6 6 into 14. So now 6 6 6 into multiplied with 14. 24 6 to 6 6 to 6 6 6 6 6. So 4 12 13 13 9. This is 93324. 93324. 93324 is the answer. Which is the right option? Which is the right option? Okay. So that means we need to change the option. Now third option will be the right option. Third option will be the right option. Okay, let us all concentrate. Okay, now let us move to 25th problem. 25th problem. The sum of all the numbers formed by taking all the digits from 3 4 5 6 7 is first option 6 6 6 6 5 sixes and 2 zeros. Second 5 6 6 6 6. Third option 6 6 5 6 6 0 0. Fourth option 6 6 5 6 0. Right. The sum of all the numbers formed by taking all the digits from 3 4 5 6 7. That means n is 5 here. That means solution, the sum of all the numbers equals to 5 minus 1 factorial. Here 5 ones we need to write 1 1 1 1 into sum of the digits 3 plus 4 plus 5 plus 6 plus 7. Okay, now this equals to 4 factorial into 1 1 1 1. This is 7 12 18 25. That is 4 factorial is 24. 24 into 1 1 1 1 into 25. See, 25 into 24. 25 into 24 is how much? 24 5 ja 120 48. 600. So this will be now 600 multiplied by 1111. 6 5 sixes and 2 zeros. This is answer. Right. Not answer 600. 600 multiply by 111. 5 ones. Option 1 is the right option. Okay. 26th. 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 The number of ways in which four letters can put in four addressed envelopes so that no letter goes into the envelope meant for it is first option 7, second option 9, third option 4, fourth option 2. This is the question. Right. The number of ways in which four letters can put in four addressed envelopes so that no letter goes to the correct envelope, so that no letter goes to the envelope meant for it. That means that's actually in different way. Here see, for example, this is letter 1, letter 2, letter 3, letter 4. Suppose you take this is envelope 1, envelope 2, envelope 3, envelope 4. According to the actually L1 must go to the even, but according to the problem no letter goes into the envelope meant for. L1 should not be placed in E1, L2 should not be placed in E2, L3 should not be placed in E3, L4 should not be placed in E4. Understood now? That arrangement's number of ways you need to find out. Here one new concept is there, that is called dearrangements, but that we have not discussed, but only for the sake of entrance point of view, competitive entrance point of view we discuss. So that's why we need to find out number of dearrangements. I will give the formula, don't worry. Number of, this is shortcut formula, this is called number of dearrangements. For example, n letters are there, n envelopes are there. that I will write here n factorial multiplied by 1 minus 1 upon 1 factorial plus 1 upon 2 factorial minus 1 upon 3 factorial plus 1 by 4 factorial plus minus so on dash dash plus minus 1 to the power of n 1 upon n factorial. This is the formula. Substitute actually here n equals to 4. That implies required number of ways. Required number of ways is equal to 4 factorial into 1 minus 1 by 1 factorial is 1 only plus 1 by 2 factorial. It should be continued up to 4 factor only. Yes, that's correct. D of n minus 1 by 3 factorial plus 1 by 4 factorial. Stop. So you need to simplify this one. 4 factorial is equal to 24. So here see simplification. Simplification you see. I will do the simplification. 24 multiplied by 1 gets cancelled. 1 by 2 factorial is 1 by 2 minus 1 by 6 plus 1 by 24. Multiply each element with each. Open the bracket. 24 into 1 by 2 12. 24 into minus 1 by 6 4 1 9. So this equals to 9. 9 D arrangements you will get it. So second option is the right option. Second option is the right option. (27) If n plus 1 p5 is to np5 equals to 3:2, then n is first option 8, second option 14, third option is 10, fourth option is 6. Tell me answer now. This is meant for you. Already this kind of problems already we have completed in the previous one, but this level is level 2 problems these are. Now these are the level 2 problems. You try yourself. Option 2. Okay, how did you get option 2? Okay, 14. Right. Muki Punvita. Right. Night PUBG. Avinash. Narla. Pavan Kumar. Right, very good, very good. Prasanna, even simplification. Wonderful, wonderful. Okay, Lavanya, Swati, Kirti. Thank you, Nana. Thank you all. Good. Okay, let me do. Please check my method, all of you. This can be written n plus 1 p5 upon np5 equals to 3 upon 2. Now this can n plus 1 p5 means 5 places can be filled with n plus 1 objects. N plus 1, n minus 1, n minus 2 and n minus 3. Stop. 5 places are filled. Upon np5, n minus 1, n minus 2 and n minus 3 and n minus 4. Stop. This equal to 3 upon 2. Now what we need to do? We need to cancel the common terms. n minus 1, n minus 2, n minus 3, n minus 2, n minus 1, n minus 2, n minus 3 cancelled. we have now n plus 1 upon n minus 4 equal to 3 by 2. Cross multiplication takes place. So if you cross multiply, you get like this: 3n minus 12 equals to 2n plus 1. 3n minus 2n equals to, this will be 2. This will be 2. 3n minus 2n equals to 12 plus 2. So n equals to 14. Second option is the right option. Second option is the right option. Okay. If you won't understand this one, go through the part 1 and part 2 of P and C. Then you will get an idea. Then you will get an idea. Twenty-eight. Okay. Right. NPR equals to 3024, then n comma r equals to, first option 4 comma 9, second option 9 comma 4, third option 9 comma 6, fourth option 6 comma 9. Fourth option 6 comma 9. So that these kind of questions should be done. So we need to express 3024 as the product of two consecutive numbers. Sorry, product of the consecutive numbers. Consecutive numbers means difference must be 1 1 1. Yes. So that means first of all you take 3024. The 3024 can be written like this: 2, 15 and 6, 12, 3 5 ja 15, 3 6 ja 2, 25 ja, something wrong we did. Okay, let us write directly itself only here. Now the solution: NPR equals to 3024. This we can write 9 times 9 3 ja 27. 9 3 ja 27 means 3024 should be divided by 9. 9 3 ja 27, 32. 9 3 ja 27, 54. 9 6 ja 336. Now you try with 8. 8 4 ja 32 and 8 2 ja. This 9 times 8 times 7 times 6 enough. These are actually consecutive. You check now. Okay, now so 9 8 7 6. That means 4 blank places are filled with 9 different objects. That can be written 9PR. So therefore here n equals to 9 and r 9p4. Sorry, r equals to 4. N comma r equals to 9 comma 4. Okay, second option. Second option. Okay. 29. 29. 29. If 56p r plus 6 is to 54p r plus 3 equal to 30800 is to 1, then r equals to first option 17, second option 38, third option 41, fourth option 52. What is our answer? R is equal to 4 places. 4 means actually there are 4 factors. 4 factors means we need to consider 4 places only. That is Punvita. That's why R is equal to 4. So sometimes the questions may be IPA also. Don't think even what is IPE. IPE is nothing but actually all the concepts. That's all. So without in IPE, no question will appear from even any competitive entrance examination. That's in textbook it might have given. Always you should be positive. Whenever you think of some negative thinking means you might be something. That's all. You may be distracting from the track. Right now. So now this can be done using NPR formula, because formula need to be applied for this one. Right now, here NPR equals to n factorial by n minus r factorial. Using this problem need to be cracked. So now let us write. See, 56 factorial upon 56 minus r plus 6, that is 50 minus r factorial, divided by 54 factorial by this one, 54 factorial upon 54 minus 3, 51 minus r factorial equal to 30800 by 1. You leave it now. This we need to simplify. So 56 factorial upon 50 minus r factorial multiplied by 51 minus r factorial upon 54 factorial. This equal to 30800. Now the factorial has the shifting nature. I will explain what is shifting nature. N factorial can be written n times n minus 1 factorial. Even this can be written n times n minus 1 into n minus 2 factorial. This is called shifting nature. So with the help of shifting nature, this 56 factorial can be written like this now. See, the 56 factorial can be written 56 times 55 times 54 factorial write down upon 50 minus r factorial multiplied by shifting. Actually, shifting concept we need to apply here. 51 minus r, after that you get 50 minus r factorial upon 54 factorial equal to 3800. So 50 minus r factorial, 50 minus r factorial, 54 factorial cancel. 56 into 55, 56 into 55 is obviously 3080 times here 51 minus r equal to 30800. You need to simplify. So now 51 minus r equals to 30800 by 3080. 1 ja 10. Now r equals to 51 minus 10. That will be 41. This answer. Okay. Third option. Question number 30. Question number 30. The number of five-letter words that can be formed using the letters of the word Delhi. Which begin and end with an oval. When repetitions are allowed. Repetitions, fine. Repetitions are allowed is first option 125, second option 625, third option is 500, fourth option 1350. This is the question. Just read the question first of all. Look at the screen, all of you. Please look at the screen. I think screen is visible to you, all of you. Right. See, let me read the question first of all. The number of five-letter words that can be formed using the letters of the word Delhi which begin, end with vowel. This is also one of the keywords when repetitions are allowed. That means actually take 5 places now. 5 places. 1, 2, 3, 4, 5 places. Okay, Venkateshalu, take a bite. You are very proficient, I know. You can make a move. Right. Solution. Number of letters number of letters is equal to 5. Here 5 letters. Out of 5 letters, now vowels you need to take. E and I. Vowels. Vowels E, comma I. 2. So what is the condition actually here in this problem? The word begin with and end with vowel. First and last place should be always filled with the vowel. So that can be done like this now. See, this can be filled 2 ways. Repetition allowed. This can be filled 2 ways. Already fixed. Now the remaining 3 places can be filled out of 5. Even vowels may be filled. That means this can be filled 5 ways. This can be filled 5 ways. This can be filled 5 ways. Understood all of you now? So now therefore, number of words equal to 2 times 5 times 5 times 5 times 2, which equal to 2 into 5 10, 10 into 10 100 into 5 equal to 500. 500 is the right answer. 500 is the right answer, not 5. Yes, 5 cube. 5 cube into 4. Sumant. Okay, right. Right. 31. 4 dice are rolled. This is very important. 4 dice are rolled. 4 dice are rolled. Then the number of possible outcomes. Number of possible outcomes is, first option 5 raised to 4, second 6 raised to 4 minus 5 raised to 4, third 5 raised to 4 minus 3 raised to 4, fourth option 6 raised to 4. This will be useful for probability also. This will be useful for even probability chapter also. Okay, now let me come here. One minute, I will come. Okay, so now you can make a move. Right. This is the first cube. This will be the second cube. Third cube. Fourth cube. This will be the fourth. Okay. Actually, you see, this has 6 faces. This has 6 faces. This has 6 faces. This has 6 faces. That means actually 1 to 6. This one, 1 to 6. This one also same. Each one 6, 6, 6, 6 faces. So required number of ways is equal to required number of ways is equal to 6 into 6 into 6 into 6. That we can write 6 to the power of 4. This answer. Okay, thank you. So now daily actually I would like to update myself to make use of the technology, because it is inevitable for this situation, in this COVID situation, very pity situation for us actually, to reach the children. So I need to use more technology knowledge. I need to develop myself. I need to learn myself also. That's why sometimes frequently, generally I use this softwares also. Okay, right, thank you. Right, here option is the fourth option, 31 question. Okay, that means number of possible outcomes equals to, on the first die 6, second die 6, third die 6. Already it has been visualized. That is 1296. You will be getting 36 into 36, 36 square. Right. Option 4 is the right option. (32) The number of ways which can be so if anybody claims that I know everything, means that is the ignorance of the person. I know means that indicates for it that ego. You need to leave I word from your dictionary, because you need to learn more, update your more. Somebody actually questioned me in the chat. I have checked it. That is their ignorance. That's all. Nobody is absolute. The number of ways which can be formed using the digits yes, 1 2 3 2 3 3 4 is After completion of this P and C, I will explain probability, because the probability is actually based on P and C itself only. First option 420, second option 840, third option 2520, fourth option is 5040. Right now, your first number of total digits write down. Number of digits. Number of digits is equal to 1, 2, 3, 4, 5, 6, 7. But out of them actually 2 is repeated for 2 times. Number of 2's equal to 2, and 3 is repeated for 3 times. Number of 3's equal to 3. Rest of them are 1 and 4 are different. Therefore, now number of ways is equal to 7 factorial upon 2 factorial times 3 factorial. 7 factorial. What is 7 factorial? Anybody? What is 7 factorial? Answer to the question. Answer to the question. Don't say 420. 420. 7 factorial is how much? Are we ready? Be in the limits. Be in your limits. 50, 40. 2 factorial means 2. 3 factorial means 6. 6 7 ja 42, 6 8 ja 48. 6 4 ja 840. That means 420 is the right option. Okay, 33. Because Mr. RB Reddy, we should not actually comment any others also. Please do remember. So community guidelines are there, we need to follow ourselves. Only as a part of my duty is actually I will educate you, that's all. Because you need to live in the society. Right. 33. The number of other permutations of the letters of the word simpleton taken all at a time is no Avinash, actually I am speaking in general, not particular about the 1 or 2 persons. This because I need to actually, even besides being a teacher, I need to educate even the other students too. Right. At least one person may change. First one 8 factorial upon 2. Second one 8 factorial minus 1. Third one 9 factorial upon 2. Fourth one is 9 factorial minus 1. Right. But everything you can say, Mr. Ravan, but you should be positive. Solution. The number of letters in the given word. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 are different only. But actually this is the keyword in the problem. Other is the keyword. Except this word, the rest of the word we need to find out. So generally the number of permutations we shall get 9 factorial, but among them simpleton will be one amongst them that need to be subtracted. Therefore number of other permutations or arrangements equals to 9 factorial is total. In this, among this word will be there, this will be present, so we need to subtract this word. 9 factorial minus 1. Fourth option is the right option. Fourth option is the right option. Okay, so now tomorrow we shall continue this session, permutations and combination session. That is actually a tendency of the children, Suma. Generally in the classroom, LKG sections, UKG sections, generally one will comment on others. That in that age, always they will compliment others. That is the psychology of the kids psychology. We need to bear all these things being a teacher. It's a very difficult task. Thank you, bye bye, see you. So we shall meet you in the evening session. Okay, I hope you might have enjoyed this class. Okay, regarding this, if you have any feedback and suggestions in the chat box, you can give it. Thank you. Take care all of you. Have a nice day.